Imagine a world where information moves through space faster than ever before. Not through towers on the ground, not through cables buried under oceans, but through silent beams of light connecting satellites high above the Earth. At first, it sounds like science fiction, the kind of idea that belongs in a futuristic movie rather than in the real world. Yet today, this vision is becoming reality. Thousands of satellites are circling the planet, forming an invisible web that promises to bring fast internet to the most remote deserts, mountains, villages, and oceans. At the center of this transformation lies a powerful idea: communication through lasers in space. This is the story of how Starlink's laser links are changing the way humanity connects, and why this technology represents something much bigger than faster internet. It represents the belief that innovation can reshape the future of civilization itself. The world has always depended on communication. From the earliest signals sent through smoke and fire, to radio waves traveling across continents, every generation has searched for faster and more reliable ways to share knowledge. But as the digital age expanded, the limits of traditional systems became clear. Radio signals from satellites must often travel down to ground stations before reaching another satellite, creating delays and bottlenecks. When millions of people depend on instant communication, even a small delay can make a massive difference. This challenge inspired engineers and visionaries to search for a new approach, one that would allow satellites to talk directly to each other without needing the Earth as an intermediary. That is where optical inter-satellite communication enters the story. Instead of using radio waves, satellites send tightly focused laser beams between one another, transferring massive amounts of data at extraordinary speed. Light becomes the messenger, traveling across the darkness of space with precision and efficiency. It may sound simple, but the reality behind this technology is astonishing. A laser beam traveling between satellites must remain perfectly aligned, while both satellites move thousands of miles per hour around the Earth. The engineering challenge is enormous, yet the reward is even greater. Laser links can transmit data faster, with less interference, and across longer distances than traditional radio systems. In the vacuum of space, where there are no clouds, no atmosphere, and no obstacles, lasers can move information with incredible clarity. This breakthrough allows satellites to form a network that acts like a global highway for data. Instead of routing signals down to Earth repeatedly, information can travel from satellite to satellite across the sky until it reaches its destination. The result is lower latency, faster speeds, and the possibility of connecting every corner of the planet. When people think about the future of technology, they often imagine new gadgets or faster computers. But sometimes the most powerful innovation is invisible. It happens quietly above our heads, beyond the blue sky, where machines work together to create opportunities for billions of people. Visionaries like Elon Musk have often emphasized that progress requires bold thinking and a willingness to challenge the limitations of the present. The development of laser-linked satellites reflects that philosophy perfectly. It is not just about building a network. It is about proving that humanity can design systems capable of supporting a truly connected planet. For students in remote villages, explorers in distant oceans, researchers in polar regions, and communities far from traditional infrastructure, this technology could open doors that were once impossible to imagine. The internet was once a luxury for a small portion of the world, but the dream behind Starlink is far more ambitious. It aims to create an orbital backbone of communication that surrounds the Earth, delivering knowledge, opportunity, and connection to anyone with a small receiver and a view of the sky. And as this network grows stronger, the question is no longer whether space-based internet will shape our future, but how dramatically it will transform the way humanity shares ideas, learns, and builds the next generation of innovation. For a moment, imagine the silence of space, a vast and endless darkness where thousands of satellites move in perfect rhythm around the Earth. Each satellite is traveling at incredible speed, yet within this motion exists a delicate choreography that must remain precise to the smallest fraction of a degree. Somewhere within this silent ballet, a narrow beam of light suddenly activates, invisible to the human eye, but carrying massive amounts of information. This beam does not travel down to Earth first. Instead, it stretches across space from one satellite directly to another, forming a bridge of pure light between machines moving thousands of miles per hour. This is the quiet revolution happening above us, and it is the reason Starlink's laser links are considered one of the most important technological breakthroughs in the future of global communication. For decades, radio frequencies have been the foundation of satellite communication. They allowed signals to travel great distances and enabled the first generation of global connectivity. Yet radio technology has limitations that become more noticeable as the demand for data grows larger every year. Radio waves spread out as they travel, which can cause interference and reduce efficiency when many satellites attempt to communicate at once. They also require large spectrum allocations, which are limited and heavily regulated. As billions of people depend on faster internet, these limitations become obstacles that slow progress. Engineers began asking a bold question. What if satellites could communicate the same way fiber optic cables transmit data on Earth, but without the cables? The answer was optical communication through lasers, a technology that transforms space itself into a high-speed data highway. Laser links create extremely focused beams of light that carry data between satellites with incredible precision. Because the beam is so narrow, it experiences far less interference compared to radio signals. The result is faster transmission, greater security, and the ability to move enormous volumes of data across space with minimal delay. But achieving this capability was not simple. Imagine two satellites moving around the Earth at nearly 17,000 miles per hour, while remaining hundreds or even thousands of kilometers apart. For a laser beam to connect them, both satellites must maintain perfect alignment, despite their extreme velocity and the gravitational forces acting on them. Even a tiny miscalculation could break the connection. Engineers had to design advanced tracking systems, capable of detecting another satellite, locking onto it, and maintaining that lock with microscopic precision. This challenge required years of research, experimentation, and relentless determination. During the development of these systems, there were moments when success seemed uncertain, when the complexity of the task pushed the limits of modern engineering. Yet innovation often emerges from the willingness to pursue ideas that initially appear impossible. The philosophy often associated with Elon Musk reflects exactly this mindset, the belief that the future belongs to those who are willing to build what others only imagine. Starlink's laser network represents more than a technological upgrade. It represents a shift in how humanity builds infrastructure. Instead of relying solely on ground-based networks, the world is beginning to construct a communication backbone that exists in orbit, constantly moving, constantly adapting, and constantly expanding. With every new satellite added to the constellation, the network becomes stronger and more capable. Data can travel across continents through space in milliseconds, jumping from satellite to satellite until it reaches the nearest ground station to its destination. Yet in the middle of this incredible progress lies a quiet suspense, a realization that humanity is only at the beginning of understanding what such a system can truly accomplish. If satellites can exchange information through lasers today, what might they achieve tomorrow when artificial intelligence, advanced navigation, and even interplanetary communication become part of the same network? Now imagine looking up at the night sky and realizing that beyond the stars you see, there is an invisible network constantly working to connect humanity. Satellites glide quietly through orbit, exchanging beams of light that carry knowledge, communication, and opportunity across the entire planet. What once required massive cables buried beneath oceans or towering communication infrastructure on land can now travel through space itself. This is the promise behind Starlink's laser links, and it represents far more than a technological upgrade. It represents a new chapter in human progress, one where distance no longer defines access to knowledge or opportunity. For generations, millions of people have lived in places where reliable internet was either slow, expensive, or completely unavailable. Remote villages, isolated islands, and distant research stations often remain disconnected from the digital world that others relied on every day. Education, innovation, and economic growth depend heavily on access to information. Yet geography has long created barriers that were difficult to overcome. The vision behind a global satellite network challenges that reality. By creating an orbital internet backbone powered by laser communication, Starlink is attempting to remove the limits that once separated people from the world's knowledge. A signal can now travel across space through multiple satellites before returning to Earth exactly where it is needed, reducing delays and increasing speed in ways traditional systems could never achieve. This kind of progress reflects a broader philosophy that has shaped some of the most ambitious technological efforts of the modern era. The idea often associated with Elon Musk is that humanity should never settle for incremental change when revolutionary improvement is possible. Building reusable rockets, launching thousands of satellites, and connecting them through lasers in orbit all follow the same principle. If the goal is important enough, the challenge is worth pursuing. Starlink's laser network demonstrates how persistence, engineering excellence, and bold imagination can combine to create something that once seemed impossible. But the deeper meaning of this technology goes beyond engineering. When communication becomes truly global and nearly instantaneous, the flow of ideas accelerates dramatically. Students in remote communities can access the same information as those in major cities. Entrepreneurs can build businesses from places that were once isolated from the digital economy. Scientists conducting research in extreme environments can share discoveries instantly with colleagues across the world. The power of connection multiplies human potential, and every improvement in communication infrastructure expands what societies are capable of achieving together. Somewhere above the Earth, a laser beam silently passes from one satellite to another, carrying data that might help a student learn, a doctor communicate, or a researcher make a breakthrough discovery. That quiet moment represents the future unfolding in real time. The network continues to grow, satellites continue to launch, and the invisible web of light surrounding our planet becomes stronger every day. What started as an ambitious concept is gradually becoming a foundational system that could support the next generation of global innovation. When people look back on this era decades from now, they may recognize it as the moment when humanity began building a true digital infrastructure in space. The transformation may appear subtle from the ground, but its impact will shape education, business, exploration, and communication for generations to come. And perhaps the most inspiring part of this story is the reminder that the future is not something that simply happens. The future is built by people who are willing to imagine possibilities that others cannot yet see, and then work relentlessly to turn those possibilities into reality. If you're benefiting from our topics, please subscribe, like, and turn on the bell notification so you can see our new videos early.